This is lesson 4-3, Simplifying Expressions, and it starts in your workbook on page 210. All right, here is example number 2 on page 211. So they want us, here's our problem, they want us to simplify it. That means we're going to combine like terms. And if you remember, we're going to rearrange them so that like things are together, and then we're going to group them. All right, so they took the x's first and they counted them up, and we have 1/3 x and a negative 1/5 x, and they put it right there. They changed that that negative to a subtraction sign. And we have this constant and that constant. Remember, a constant's a number without a variable. And we put them together. And then I would suggest using your fancy calculator. We know how to use those fancy buttons. So when you put in 1/3 x minus 1/5 x, you will get 2/15 x. And when you plug this in, you will get negative 7 5/10. Those are perfectly fine separate. We are not going to combine them together, and we are done simplifying that expression. Okay, it's time for you to try. This is the example 2 try-its. I want you to go ahead and do both of these. When you are done and you're ready for checking, I want you to come back. All right, so let's try A down here. I'm going to count up my m's. So I have 59 and 95/100 and 7 and 95/100 and 9 and 49/100. I'm going to add those all together, and I will end up with 77 and 39/100 m. But I didn't just have m's. I also had some constants. I had a negative 30 and a 45. If I add those together, I will get 15. And those are definitely fine separately, so that is your answer. Give yourself a star should you have had it right. Fix it if it wasn't. Okay, let's go ahead and do letter B. I'm going to add up all these p's. I have negative 0.5 p, and I have half a p, and I have 2/3 of a p. If you pick up your fancy schmancy calculator, this is going to end up with 2/3 p, but I wonder if it gives it to you as a decimal. If it did, it was a repeating decimal. It'd be 0.66666 till the end of time p. Added to that, I only have one constant, which means it just gets attached. These are totally fine separate. That is your simplified answer. Go ahead and give yourself a star should you have had it, or fix it if it was not correct. All right, this is example number 3 on page 211. We're going to start off using that commutative property. We're going to take 4a's minus 3a's. We're going to take negative 5b's and 2b's, and we're going to end up with a negative 6. All right, commutative property just means I'm going to move them around. Now the associative property says if I add subtract 4 minus 3, I'll get 1a. If I do negative 5 plus 2, that's negative 3b. And then that's all by itself, so it just comes down. Now for me, I don't like those subtraction signs, So an alternative answer might have been 1A and a negative 3B and a negative 6. Those are equivalent. Either one of those would work as your answer. All right, this is the try it example 3 on page 211. And I want you to try this on your own, and then when you are ready, come back and check. Okay, I guess my dog's going to cry while we're doing this. Anyway, let's ignore her for a minute. All they did was they started with the commutative property, and they started looking for the g's. We have 5 g's and negative 10g. Added to that, they started looking for their k's. A 4k. There wasn't any more. So then they started looking for their constants. Negative 3.7 and 11.1. All right, so let's add these g's up. 5 minus 10 is negative 5 g's. They just brought down their 4k's. And on a calculator, if you take negative 3.7 plus 11.1, you get 7.4. So our final answer is negative 5 g's plus 4k's plus 7 4/10. All of those are different, so we will not do any more combining. Give yourself a star should you have had it right. Fix it if you had it wrong.